So let us go through the second problem of this project Euler plus, where we have to find the sum of all the even Fibonacci numbers. I will explain you the problem statement using examples. So if you want to go through in detail, you can just go through the link which I have provided in the description. So you can check that. Okay, so you know what the Fibonacci numbers are, right? So all the numbers starting from 0, 1, so keep on adding. So here in the example, they have given 1 starting with 1 and 2. It doesn't matter because the logic, it doesn't affect the logic. Okay, so what we need to do is we have to filter these numbers to get only even Fibonacci numbers. Okay, so we get 2, 8, 34, 144, 1610, and so on. So once we do that, we will be given with the input n. Okay, so n is equal, for example, 100. Then we have to take all the Fibonacci number below 100, that is 2, 8, and 34, and we have to add them up. So our answer will be 34 plus 8 plus 2. Okay, so it will be 44. Okay, so that is what we need to display. That is our output. Okay. Let us try to understand using more examples. But before that, we will try to understand what is the input constraint. So, or input limit. So we have test cases from 1 to 10 power 5, and the n can be from 10 to 4 into 10 power 16. So if we try to list down all the numbers, all the Fibonacci numbers below 4 into 10 power 16, we get this list. Okay. As you see here, we do not have so many numbers because when you keep on adding up numbers and the result will become very huge, right? That's why, I mean, even though it looks like very 4 into 10 power 16 is a very huge number, uh, I mean, the list is not very big. And if we filter this list to list down only the even numbers, we get this result 2, 8, 34, and then we have 144, then 610, and so on. So from here, let us try to understand more examples. What if n is equal to 4 into 10 power 16? Then in that case, we need to add all the numbers from in this list. We can just use the sum formula to this list and we get the output. But if n is equal to 10,000, then we have to up to here we have to stop. So from 2, 8, 34, 144, 610, and 2584. We have to add these numbers. What if n is equal to 10,946? Then also we have to consider this array, because if it is 47, then we have to consider that 10,946. Since it is exactly equal to that Fibonacci number, one of the Fibonacci number, then we have to consider this. Okay, just note on this, note this point. Okay. Now let us try to build the logic for this. So I'll be creating a Python code and logic together. So I'll explain you like step by step. So here first we will try to save the Fibonacci numbers and Fibonacci even numbers in two lists. Uh, what we are interested in this only in this Fibonacci even numbers list. Okay, so if you remember, so last slide I have shown you all the Fibonacci numbers which are below 4 into 10 power 16. So since these are Fibonacci numbers are constant, you can directly save it directly instead of generating during runtime. So, but here, if you want to generate them during runtime, this is the code for you. So, what we have to do is, while Fibonacci numbers, last two numbers, sum of last two numbers is less than or equal to 4 into 10 power 16. In that case, just um, um, add them to the, just append it, okay, that particular sum, okay. And if the mod of 2, for example, if that particular number is divisible by 2, then add that number to a Fibonacci numbers even list. Okay, I hope this is clear. So now let us go try to read the inputs. So first we need to read the total test cases. Then we have to, for every test case, we need to read the input. So what we will do here, since the list Fibonacci number even list is in increasing order, we can try to do divide and conquer method. So we try to find the middle point, middle index, and we try to see whether that particular number, Fibonacci number, is lesser than or greater than n. Okay, and we'll try to find out that particular point till where we need to find the sum, and then we will just directly use the sum function. Okay, so first we'll try to have a start index is obviously is equal to 0 at the beginning. Then we have end index, which is nothing but length of Fibonacci numbers even, and we will have a infinite loop, and we'll try to break it. I'll tell you how to break that. So first we'll find a middle index, and if the middle index is equal to starting index or the ending index, then break this particular loop. Okay. Now for our example, let us consider n is equal to 10,000. So whatever array you see here is nothing but the Fibonacci numbers even. Okay, even list. So this particular list, what happens is that starting index is 0 and ending index is the, like here, the last one, the total length of the list. And what we need to do is, like, we need to find out the middle index, okay, which will come maybe somewhere here only. Okay, then we'll check whether it is greater than or less than is n. Okay, currently since this number will come here, so obviously it is greater than n. So what we need to do is we have to rearrange the end index to mid index. Okay, starting index will be 0 only, but if it is lesser than n, then we have to shift the start index to mid index. Okay, that is how you need to do it. Once this you keep on dividing this until you reach this point 2584. Okay, and then what you need to do is just find out the sum of all the Fibonacci numbers even till the mid index plus 1, because we have to consider that particular number as well. Okay, so yeah, that's it for this video. So I hope this is clear. So let me know if there are any doubts in the comment section. Thank you very much.